Hey, so I'm Hagen, and this is the halfway report for my QM238 project 3. So the first thing I did for the project was I imported pandas. I did import pandas as PD. I then read the data set which was given to us. So I did df equals pd.read. I did the read underscore CSV function, and then I plugged in the data set which was given to us. I then displayed the top 5 rows by using the head function, and I plugged in 5. I then used the tail function and plugged in 5 to display the bottom 5 rows. Then I did the data frame dot shape function, and I got the shape. The data frame was 18,835 rows, or 18,835 different songs, about 15 columns or attributes. So the next thing I did was display all of the data by just using df. The next thing I did was I displayed the different data types. So the song name attribute was categorical, but all the other attributes were binary, so easy enough. And then provided a statistical summary of all the data by using the df.describe function. The count will be how many different things there are within that attribute, how many different songs there are. The mean, what was the average, the standard deviation, the minimum value, the first quartile, the median, the third quartile, and then the maximum amount. The next thing I did was to check for missing values. I used the df.isNull.sum function, and as you can see, there were no missing values. The next thing I did was check for any duplicate values. I did the .duplicated.sum function, and there were 3,900 different duplicate rows. So the next thing I did was drop those duplicate rows by using the drop duplicates function. And as you can see, it reduced the number of rows I had. So then I imported Seaborn and matplotlib.pyplot into Jupyter Notebook, and then I created a box plot to see the outliers I had. As you can see visualized, there were a good amount of outliers in the song duration attribute. So what I did was drop those outliers for the song duration attribute. Firstly, I defined the quartile 1, I defined quartile 3, and then I defined the interquartile range by subtracting the third quartile from the first quartile. I set the threshold as 1.5, and then I defined what the outliers were by using the first quartile, the threshold, the interquartile range, the third quartile. Then I did the df.drop outliers function, which dropped all of my outliers for me. Easy enough. And as you can see again, the number of rows was reduced. So the next thing I did was create a correlation matrix. So usually a correlation of 0.3 or 30% is a significant correlation. So looking specifically at the song popularity attribute, since that is our target, there was not anything that met that 30% threshold, so there was not significant correlation. However, I chose to look at the 3 highest correlations. As you can see, instrumentalness had a had a 8% negative correlation. Danceability had about a 6% correlation, and then loudness had about a 5% correlation. The next thing I did was to create a heat map to further visualize that correlation, and as you can see, there was not much correlated with song popularity. So the next thing I chose to do was to create scatter plots or visual or to essentially visualize the attributes with a three highest correlation. So firstly, I did instrumentalness, and I got this scatter plot, which seemed to be all over the place. I then did danceability, and it was more linear cluster than instrumentalness, but still not exactly linear, but as you can see, it's a lot more clustered together. The next thing I did was loudness, which was the third highest correlation. And as you can see, it was better than instrumentalness, but there was still a lot of deviation. As you can see, there's a wide range of outliers. So the next thing I want to do was to kind of further standardize my data, or not really standardize, but to get rid of one thing. I went ahead and dropped the song name attribute because it was categorical, so it does not matter for any regression purposes. The next thing I did was I sampled data to reduce the size of it. I did a sample with replacement, and I set the sample size to 500. As you can see here, it gave me 500 rows. The next thing I did, lastly, was I created a scatter plot with the sample data. As you can see, I need to go back and fix that because we chose danceability. Yeah. So let me fix that right here. So maybe I will do instrumentalist. Okay. Yeah, as you can see, this gave me a more linear function, so I think I'm going to keep it with instrumentalness as my projected attribute for now. So that's my halfway report. Thank you.